Evening. So welcome to 252A, transportation modeling. Right. So my name is Karthik. I'm one of the lecturer in UP Diliman. And today we discuss, because this is our first meeting, so we will discuss about course syllabus first. Yeah. So you can follow all my materials in Moodle, in Revoledo. I think I sent you the links last week. Okay, and we cancel our meeting last week. Okay, so where is sharing? Here is our course syllabus. So you can first you can contact me via email. Okay, when you contact me via email, because subject, so you put in the subject PLAN252. Yeah, and then this is my WhatsApp number, so you can contact me via WhatsApp, also Viber, or Facebook. This is my Facebook, okay, or Telegram or Viber. Yeah? So, and you can contact me anytime, even in the evening, but please expect that there is a 24-hour delay. I will not answer immediately to you, okay? Our course is about transport modeling, okay? So this is an applied course, okay, on transport planning and traffic engineering. So we will build a theoretical foundation, okay, to cover the latest advancement in transport modeling, okay, including traffic engineering. Yeah. So we will discuss about transport supply, transport demand, and then, of course, more on the model definition, how we will apply some algorithm to some basic scenario. Okay. I hope we will discuss two parts, yeah? So macroscopic and microscopic simulation, as well as how to design the transport system. Okay? So of course, this is very crucial to evaluate intervention on infrastructure and service network. Yeah? And you will try to implement how to do what's called mobility policies. Yeah? So how to move people rather than just vehicles. Okay? So the ultimate goal is, of course, to provide some comprehensive understanding about various modeling technique, yeah? And to assess the impact of transport modeling, planning, and decision policies. Right. So this is the course objective. So we will apply the application of transport modeling, especially in transport supply and demand. Okay, and then you try to create some kind of policies in terms of network intervention in the infrastructure, and then you identify the strength and weakness. Okay. Next, you use this model to predict, yeah, to evaluate about decision that you propose. Okay. Now, this is an output-based course. That means we are hoping that the students must be active, and our goal is to create software in public domain, okay, in GitHub, or not and. So a published paper or report with the code and analysis. Okay, so you will do case study on simulation, okay? Case study and the scenario comparison, and then you try to contrast the base scenario with the alternative scenario, and what is the novelty of this. Okay? If you make a paper, so I'm hoping that there is some kind of originality, okay, and uniqueness on this, right? So the topic that we will discuss include the following. Yeah? So activities and land use transport interaction today. So next meeting will be on traffic flow theory. Okay. And then in brief, we discuss about transport policy analysis. And then we go in depth on demand and supply transport system, as well as the traditional transport system and ideal route network. Okay. The last one, not least, is about network optimization. Right. And these are the tentative date. I updated this one. Okay, so this is today. Okay. And this is next week and so on. Okay. And every meeting we will have a assignment. Okay. And these are the plan for the quizzes. Yes. A lot. Okay. Any comments on this or possible? So this is the UP grading system. Is this correct or not? And these are the reference for the readings. I have several books where you can read. And I also provided the same books of this uh, in Moodle, so you can check. Okay. The book is already all provided. Okay. And these are the most requirement. Okay. So we have discussion and recitation, 5%. This is you claim on your own. Okay. And we have a group project. I propose 40%, and then assignment 20%, many assignments. And then the quizzes and the midterm is 15%, and then the final exam is 20%. So what do you think about this? Do you agree with that or?
Sir,
Yes.
yes. I think I saw that you scheduled a class on November 1.
Number one is wrong.
Yeah, November 1 is a holiday also.
Oh, okay.
Yes, that's All Saints Day in the Philippines.
Okay. This one. So
Yeah.
I will remove this one. Thank you.
Thank you, sir.
Yeah. So I will note that November 1 is holiday. Okay, noted. And how about yeah, and about this. Oh, can you see the course syllabus? Okay. Next. So the percentage is okay? Yes, Joven.
I just have a question regarding the quizzes and midterm. Since it's all, the total is 15%, but based on the schedule, we have many quizzes compared to one midterm. What is the ratio, sir?
Oh, midterm is supposed to be bigger. Okay. You want me to put the quizzes in the assignment and then midterm is smaller?
Okay, sir.
What do you think? Should I put these quizzes and assignment like this? Midterm is 15%, is it okay? Or you want to put midterm is 10%? You can
Yes,
put
sir.
this one 10%, the quiz will become 25. Is that what you want? If everyone agree or you have some comment? Okay, good. So a lot of quizzes and assignment. Okay, midterm is just 10%, so final is 20. Careful. And the largest is, of course, the group project. Okay, good. So if you are on time, okay, so you can claim in the recitation. Okay, so but if you are late, you cannot claim the part of 5% recitation. So every meeting, please be on time and then open your camera, okay, and you can close the mic. Okay? So you can open the mic only when you speak, and then please be active, yeah, in discussion and question, sharing your knowledge, experience, and so on. Okay, and then give your feedback. Okay, critics is accepted, no problem. Okay, and you can give it back to me or to other groups and other students as well. Okay. Now, so for the active recitation, okay, so you can go to Moodle, and then in the Moodle, you can see on the top, and you see here, yeah, in Moodle, you can see the recitation entries. Okay. And very important for you is to put the total of the recitation on the top based on your claim. So please submit it every week, okay, right after the class. Okay. So if you forget or miss some claim of the recitation, you cannot update it anymore. Yeah. Okay. So maximum is 10 points per week for students. Okay. And then it will be accumulated for the whole semester. Okay. And then later on, we will normalize based on the maximum number of points that you claim. Okay. The highest will get 100, and then say if you get if you claim, for example, 50 points, okay, and the others claim 100 points, that means you get only 50 divided by 100 multiplied by 5%. Is this clear? And okay, so it will normalize based on the maximum number of points that can be achieved by the most active students. Okay. Next, so you put in Moodle your recitation. I know it's just 5%, but you claim it on your own. That's mean quite good, right? Okay, based on your active recitation. And for the quizzes and assignment, so they are designed to test the preparation for the student before the classes or review previous classes. Okay, so the assignment is usually practice on problem solving. Okay. Now, this quizzes and assignment we will put a different way. Okay. So usually I use Fibonacci weight. So that means so the first assignment and quizzes is 1. The second one is 1. And then 1 plus 1 become 2. And then 1 plus 2 become 3. And then 5, 8, 13, and so on. Yeah. So what does it mean? Meaning the last assignment, okay, is the largest weight. So if you miss the first assignment or the quizzes, that's okay. But if you miss the last one, you are in trouble because the percentage, the weight is becoming much bigger. Is this clear? Now the 40% project, yeah, you try to solve traffic congestion in certain area. Okay, so either you will build your own microscopic traffic simulation, say for example using animation, yeah. In this case, no data is required, or you can just use the transport modeling tool. Yeah. In this case, data is required to calibrate. Okay, so I provided the IFN transport. You can check in model. Okay, and can go. There are many different versions. Okay. One is online. The other one is in Python. You can also use the Excel part of IFN transport. Okay. And then the goal is to create some optimization model, yeah, to calibrate using real world data, and then to perform some numerical experiment through the simulation of several scenarios. So either you build the traffic simulation or use the transport modeling tool. Please do what is called what if analysis. Yeah? So you define several scenarios. Okay? The current condition is called base scenario, and then you create alternative scenario, how to improve compared to the current condition. Okay? So the goal is to publish a paper or a published software in public domain, yeah, in GitHub. So you can grouping up to 3 students per group. Okay, today you can find grouping, and then after that, once you set the group, so there is no change. Okay. For today, you can put individually in model. So who will be your group mate? That means you can keep a name of the group and so on. Okay. After that, I will set the group in model so that every time you submit it for the group project, it will be only one submission. But only for today, you need to submit individually. Yeah. So you're free to use any device, any programming language, okay, for the implementation, preferably in Python or in web-based. Okay? And if you are submitting the code, so please submit it in Moodle and to the GitHub. Yeah. So the code will be used by other people, so it's publicly using your own name. So please make enough documentation, yeah, so that people can also use your work. Okay. So now you can use AI. In fact, I encourage you to use AI in this class. Okay. So you can use any AI that you want. So you can, these are listed the most well-known AI. So you can use Cursor AI, Blackbox, Copilot, Gemini, ChatGPT or Perplexity, and so on. So for coding, usually we use Blackbox or Gemini. Okay, so it's really encouraged for brainstorming and to code. Yeah, but the end result for the project, that is the paper and the report, must be free from plagiarism and pass the AI detection tool. Okay, for the coding is no problem. You can use AI. Yeah, so all your prompt of the AI and the answer of the AI must be submitted also as part of the report. Is this clear? Okay. So paper is optional, right? So either you build the paper or build the software. That means if you choose to create a paper instead of building the animation software, okay, you summarize your report, rewrite it in a more scientific way. Okay, these are usually what you need to write in the paper, right? So the background, how do you develop the ideas, okay, the literature review, what the others have done similarly, so what is compared to yours, and then the formulation of your ideas, and then do the analysis and testing, okay, and compare, and finally you create the conclusion. So including my name is not required. So if you think I have contribution, you can put. If not, no need. Okay, so the paper you can use ACM or any journal of your target. Okay, usually between 8 to 16 pages, double column. Okay, and please use tracking review, okay, in Microsoft Word or in the Google Doc, so that we will know what is the revision. Okay. So if you want to include my name, I need to keep my brand name intact. So please read this one. Okay. So important now that all the project report and assignment, yes, you can make it late, no problem, but you cannot go beyond the final exam date. Okay. If you submit it after the final exam date, it will not be accepted. Anyway, Moodle cannot accept you also, right? So if you miss the actual deadline in Moodle, okay, you can still submit until the final exam date, but minus 1% times the number of days of your delay. Okay, so after your final exam and all the submission, okay, I will contact your bidder so that you can check, okay, the grading, the computation of the grade. Okay, so you will have at least 48 hours, okay, before the final grading submission to the school. Okay, so if you have certain things that you want me to change, or you miss some things, I will discuss with you. Okay? But after I submit it to the school, to the OGS, no change will be accepted. Okay, is this clear enough? I think it's fair, right? I give you the computation, and then you check. Okay, if you don't have any comment within 48 hours, then I will submit. Okay, so I expect that you will be active, okay, in the class, so you can propose any ideas, okay, and give me feedback, comment, question. So what do you think? Question to you: have you ever used AI? No. Have you ever used AI? Never used? Yes, Finn Frances.
I only use ChatGPT for writing purposes, but for coding works, I haven't used it.
Okay. Do you want me to demonstrate it to you?
Sir, are we expected to no coding already because
No.
the class did not
No,
specify the that
no,
as
no,
prerequisite.
no. It's an option, right? Either you submitted the code or you submitted the paper,
Oh, okay.
right? It's an option. Okay. Nowadays people are thinking about paper is a better way to create an output, but I think that is not really a good way because the international system of journal changed so much. Okay? Paper become like commodity now. So creating paper is practically just not really useful. Nobody read anyway, right? So it's better to create certain output that actually being used by other people rather than just creating a paper that nobody really read. That's my point. Okay, why I give you options. Is that okay? Okay.
I think
I'll
that's
give you
fair.
the command. Yes,
Do have options for the final output.
yes, you have options. Okay. Now let me share with you in that case. Okay. Okay. I will share with you my ChatGPT. Okay. Can you see my screen in ChatGPT? Yes? Cannot? Can you see?
It's not yet showing.
No, sir.
No? Oh, wait. Why? I thought I'd share. Yeah. Oh, can you see now? Okay, good. So this is recorded, so you can replay later. Okay, this is the ChatGPT. I use 4.0. You can use any. Okay, so let's say you want to create an animation, right? So, okay, so you write here, I want to create microscopic traffic. No, vehicular, yeah, vehicles animation. Okay. Can you code with me for me, right? In HTML slash JS slash CSS. Okay. Before coding, can you show me the requirement? Okay. These are the keywords. The requirement, specification, and design. Specification, design. Yeah. Before coding implementation. Okay. And discuss with me, okay, the assumption that you will make. Okay, that's it. Look, press enter. So it will give you the requirement. So this is the objective, right? And this is the key feature and so on, this other. things that they will design. So the architecture is modular and so on. Okay, and after that, this is the interface, right? And then assumption, okay, discussion point, and so on. So you can answer this. Okay. So or you can directly go to the implementation. So proceed with implementation. Okay. Example only. This one later you're supposed to discuss more detail. Okay. There. So it will code for you. All you need to do is copy and paste this one. Okay. This is the CSS. And this is the JavaScript. Can you see? So, do you require to know programming? Not at all. Okay. But you need to know how to speak English. So, okay. So all you need to do is copy and paste all of these. Okay. Let me do it for you so that you can see. Is that okay? This is of course the first one, so this is very bad, but it's okay. Okay, later you can improve. So I create here a new file. Okay, so this is the new file. I copy and paste. Can you see? Okay, this is I copy and paste here from this one. Can you see that or not? Okay, so and this one I need to put as save as. Okay, so I will put in temp. Okay, I will put in traffic. Oh, no, I will put it in. Okay, I will put it here. Temp. Okay, index HTML. The file name is important. HTML. Okay. There. The next one is the second part with CSS. So all you need to do is copy again. Okay, and you create new file. Okay. And then again, what's the name here? Supposed to be. Oh, the name is. Oh, did not say. Okay, so you can either put it here or you can give the name. Okay, so and then the third one again, you have this code. Okay, you copy and paste, and you create a new file here. Paste. Okay, and you save as CSS or JS. Okay, for example, my program .js. Okay, so and then of course you can run simply by clicking okay, this one. Earlier code is what is that? Okay. When you click the index HTML, can you see you already have this? So of course this is not yet working, so you need to ask more detail about that. So what do you think? Okay, so easy, right? So I give you example there in Moodle. Where is that? Oh, there. You can see in Moodle. Okay, so this is the example of traffic animation. Yeah, it's not perfect, but at least it works. Okay, you can change the settings and so on. So certain force that you need and so on. Okay, so it will create certain queuing. Of course, later what you need to do is changing the scenario. So, for example, this is I put bottleneck here, right? Okay. So what will happen if we check? So you can go more detail later on this. Is it okay? One. Next, if you go to here in the model, and so this is the reference, the books. Okay. I have a IFN in Telegram channel, so you can join. Okay, there is also IFN transport. So open this. You click this one. There. Okay. So IFN transport is a simple program, okay, that you can use for your project. So example here is the OpenStreetMap. Okay. So you can read this. So you go to OpenStreetMap website. Here is the example of UP campus, right? And you see, so you can go to your own city. Anyone from outside Manila? Anyone? Anyone want to volunteer? Okay, the road that you're familiar with. Where? Give me any name. Hello? Huh? Okay, Vin, where is your location that you're familiar with? Probably UP campus is the one that's familiar. So all you need to do is go to this export, click, okay, and then copy this part. Yeah. Right, top, bottom, right, and left into this one, in the bounding box. Okay, so one by one, copy and paste here. Okay, and second one, copy, put it here. Okay, the third one, this one, right? You copy, and the last one at the bottom, again, you copy, so that you will not copy and paste so many times. You can download this, the one that you set. So you can also set what is the road, yeah, motorway, trunk, primary service, for example. So I save this. You see, this is the one that I just set. Okay, and then once you can also check the settings if you want to change the setting of the road width and so on. Okay, once you do that, okay, all you need to do is, or you can also simulate what is the capacity in here. So then what you need to do is to download here. this button. Okay. So when you download this fetching data from OSM, yeah, it will take sometimes. Oh, so if this is too long, you can make the thing zoom in so that you can get closer a look. So this is the map zoom at 16. Okay, this is probably the best way. So okay. If it is very big, it will take so long and probably cannot. It will fail to download because it's very big data. Okay. But if it is zoom in, okay, at I think zoom level 15 to 19, this is too long. Let me exit the page and refresh. Okay, so let's do it this way. This one, is that okay? So whenever you change this, it will go. It's not change it. So I'll copy again and come back here, the map. And this one, copy and put here. Okay. And the third one, I copy and put here. And the last one, I put copy and put here in add and spot. Okay. And then say I put until everything. Okay, save this. Okay, this is the data that we want. Right. And then I download it. Now, see, you downloaded already, and then you can go to the network tab. See, this is the data that you just download. Okay, and we have the link ID, start ID, end ID, capacity is already given, the distance and the maximum speed is already given. And you can start to see, oh, and you see that? Okay, this is because of the scaling, yeah? So if you put 50,000, there you get it. Osmania, this is exactly this map, isn't it? Osmania. Okay, can you see that? Okay, and then you can zoom in more detail and you can select the field. So in this case, you have only capacity, right? So you can zoom in more detail. Then this is the capacity. And this is the node ID. Huh? Right. Okay. Once you create that, okay, you can go up, okay, and then you set up the model. Okay. So if you have certain real flow here, you need to input the data and you set all of this. Okay. Later on, we can discuss more detail. If you want to convert from GIS, you also use this. Okay. And if you use the old version of transmodeling, you can use a capacity restraint or all or nothing. Okay. The new one is and then you can calculate here. Yeah. So let me give you the example first. This one first. This is the small network so that you can start to see. This is very big, so I think it will take long time. I will put a small network. Okay. And in here, this small network have a certain real flow. You can also put any others. So then you calculate there, you will get the result. directly, okay, the congestion level, and you will get all the detail. Yeah, the flow, congestion, speed, density, and so on. This is in macro level. Okay, so and you can export that to Excel. You want when you export that to Excel, you will see different things. You can also see that here. Okay, for example, this is the congestion level, and so on. And then you can compare later between the existing scenario and what you propose. Is that okay? Any questions so far?
Sir, are we required to use these coding tools or software in our projects, or we can use other?
You can use any others, no problem. So, but other software is like $10,000 software. This is free, and I'm the one who developed this. So if you have this make mistake, I can fix it for you. Okay, so it's up to you. You can use any software that you have. Okay, no problem. It's not required. Okay. This is the example of result a while ago. From the one that we downloaded. So these are the network, summary, and the link. So you can use Excel to manipulate this more detail. Okay. So question? Any other comment? Okay, so in that case, I will close this too. Okay, and let's go back here. So this one is the add-ins of IFM Excel in Excel. If you like to use more detailed computation in Excel. Okay, and there is also here is the Python version of that FN transport, the same thing. Okay, so the one that I put there is online, so you don't need to download. In here, you need to download. But the source code is already here. So this is including all the source code and the bugs and so on. Okay. So, and of course, this is using Python, so you need to know how to install and run Python. Yeah. Can you see? And this is the example a while ago, similar, but this is in Python. Okay. And this is the result in Python also. Yeah. And this one have more optimized optimization. For example, this is the optimization for the calibration. So the code free, so you can. I think something is wrong. Why I'm. Is this okay? Any question? Any comment? So far, so good. Okay, then. In that case, let's go to our. Okay, so in the group project today, can you just submit the name, your group name, and then the tentative topic, maybe the location, okay, of the interest, and then whether you want to use software or to create some animation. Okay, maximum 3 students per group. Yeah. Okay, so let's go to the first topic then, which is modeling fundamental. Unless you have any question regarding the course syllabus. No question? Okay. Our class is about transport modeling, right? So that's me. Zoom. I will share this. Okay. So what is modeling? Yeah. And we'll discuss type of model and then the model creation and process. So important is about model usefulness, calibration, validation, and simulation. Okay. And then some warning about modeling. Okay. So this is actually happening. Yeah. So we are what we model in our mind, isn't it? Everything that we think is actually modeled. Yeah. So every concept that we think of, every story that we can think of is actually a mental model. Okay. And when the model is accepted, okay, as our standard agreement by many people, okay, it becomes reality and it can be implemented in the physical things. Okay. Look at this way. Yeah? Any tradition, any culture is actually model. Okay. Language is actually model. Moral, the entire nation is actually concept. Okay. It is a model. So when I said model here is actually very general, isn't it? Okay. So when the model becomes shared ideas, okay, so the concept of money, okay, the real money does not exist, right? Okay. So it exists because we agree and it becomes shared idea. Okay. Before Bitcoin exists, probably you think that money is only government can make. Okay. Now everyone can make their own money. Okay. Is that correct? Okay. So as long as it becomes shared ideas, okay, and everyone agree, it becomes a standard agreement. Okay. The concept of education, religion, law, philosophy, including mathematics, science, and so on, these are all concepts that is actually a model. Okay, when I said model, this is very broad. Okay, in the ancient world, okay, they use something like this, isn't it? Right? So they think that the element of the world is like water, wood, fire, earth, and metal, and so on. Okay? And somehow they lead to different direction. Yeah? Okay, so using horoscope as a model. Okay. So in any model, okay, what you need to think of is actually the invariance. What is invariant? Invariance means something that constant. Okay. Something that does not change. Remember, yeah, in any model, what you need to think of is something that constant. This is the assumption behind. Okay, so when we put in Wikipedia, okay, these are the definition of modeling. Yeah. So in our class, when we discuss modeling, this is the one that we use. Yeah. Modeling is a process of creating an abstract or conceptual model, okay, and the use of object in creation or of the predictive statement. So this is scientific modeling. Okay. We can also use a miniature model, technical artifact, okay, or mimic certain behavior of the physical things, okay? For example, in chemistry. But this is not what we think as modeling in our class. Okay? Display the object for the other to see, for example, in the fashion show. That is also modeling, but this is not in the definition in our class, isn't it? Okay. So model is a simplified description of a system, okay, to assist us. Model is just tool, okay, to assist us in computation, okay. So this is the book about complex system, Miller and Page, said that modeling is actually similar to sex. Yeah? Despite it's important, most people do not want to discuss about it. And no matter how much you read about it, it doesn't seem the same when you actually get around to doing it. Okay. In any model, okay, hey, look at this. Any model is required some faith, some belief, okay, okay, some kind of expectation. So in scientific jargon, what we believe to be true, okay, we call that hypothesis, axioms, postulate. Okay, what is that? Something that we believe to be true. Okay, so basically we accept this as our faith. But the difference between science and religion is we don't just accept that, okay, as a blind faith, but we need to test objectively. Okay, so you need to train to be objective and honest. Yeah, in modeling, right? So there are three views of modeling. Yeah? You can think model as a concept, okay, or as a form. Then you can quantify that down. Okay, so as a concept, okay, this is an abstract view of a model, right? So you have certain principles, you have certain law or behavior characteristic that you want. This is a conceptual model. Okay, once you have that abstract model, okay, which is the concept, you can put that into a form. So what is the form of model? Usually in mathematics, okay, either relation or function. Okay, so in that case, you break down into variables. What are the relationship between these variables? Okay, so remember, you start with a very abstract concept, what you want, the principle of the model, the behavior that you want, and then you go to the form of that model. Okay, and then you quantify that model, okay, by checking the parameter values. Okay, so when you do modeling, okay, think of these three levels. Right. So the question is, why do we need to model? Right. So we model because most of decision in our real world is actually large and complex. Okay. Model is a simplified version of the real world. So if you want to do experiments in the real world, okay, then it's better to model first. Okay, look at this, especially in transport system. What happened? Without modeling, okay, this is real behavior of many government officers. Okay, they have the power of the money from the tax, okay, or probably loan, and then they create the road, or they widen the road, okay, without even thinking, okay, without even doing the experiment to optimize this decision. Okay, when you do this kind of technique that you experiment directly in the real world, how much time, how much money, how much effort that you wasted. Can you see that? Okay, but instead of doing that real world experiment, which is very expensive and affect a lot of people, okay, why don't we put that into model? Okay, we put that into computer, and then you do experiment in the computer first. Isn't that better? We simulate first, okay, and then we find the best solution in the computer, right? And then the optimum one, that is the one that you implement into the real world. Okay. To do experiment directly on the people in the real world, okay, by building the bridge, the road, widen, or any idea that you want, okay, directly in the real world is really waste of time, really waste of money. Okay, because you cannot optimize directly there, and then it takes long time to check the result, isn't it? So if you build now, can you see the result? Probably next 5 years we'll get the actual congestion. But in computer, if you put that, you can compute directly within a few seconds. You can see the result. Okay, and then you will say, oh, this is not good policy. I need to change this. Okay, that is why, okay, we need to model, yeah, to provide the efficient learning process that will increase our own understanding about the system that we deal with. Okay, to enable us to create wise decision rather than experiment directly on the in the real world. Okay, so you don't create, okay, directly experiment real world situation, directly experiment in the real world solution. So the experiment, you do it in the model. Okay, once you find the solution, that is the one that you implement as the real world solution. Is it clear? Why do we need modeling? Okay, to make it efficient. Any comment on that? Right? So now there are 3 levels of models. Any model. Okay, there are 3 levels. Okay, number 1 is descriptive. Okay, so in descriptive description of the phenomena, you see certain phenomena in the nature or in the social system. Okay, and then you describe it. How do you describe it? You find the input, you find the output, and then you find the relationship between the input and the output. So in this case, okay, the input I give name X, right? The output I give name Y. Okay, the relationship between the input and output I give name F here as a function or relation. Okay, and of course there are certain parameters here, so I give name alpha. Okay, so in the first level, you want to describe the system under your consideration. That means you need to know the input, you need to know the output, okay? You need to know the function, relationship between input and output, okay? And then you will learn to calibrate this parameter. Say you have IFN a while ago, or you create the microscopic simulation like a while ago, okay? So once you know the input and output, okay, what you need to do, you calibrate this to match with the real world. Yeah. So model calibration is to learn the parameter alpha. Okay. So once you can calibrate your model, you go to the second level, which is to predict the future. Okay. So in this case, the future that you predict is based on the model that you have in the descriptive of phenomena. Okay. So what is the invariance here? Something that do not change. In any prediction, okay, there are two things that you do not change. Number one is the parameter that you have calibrated. It doesn't change. Second, the function or the relation, okay, also do not change. Can you see that? Okay. And then you give a new input, X. Okay. You want to find the output based on the model. That is the meaning of prediction. Okay. You have the model that you have calibrated. Okay. And you have the input, the new input, this one, not based on the data, but the new data. And then you can find the new output. Is it clear? And then the third level is called control, optimization, okay? Prescriptive, okay? So what does it mean? You have a target that you want. You have the goal, okay? What is that? The goal is your output, something that you want to achieve, right? So then, okay, the same thing, yeah? The thing that invariant does not change is the function and the parameter that you already calibrated. Okay, but this time, what you have is the output. Okay, what you want to find? The input. Is this clear or not? Is this too abstract? You want me to give you example? Okay, you can try. Let's do it in Google. Charts. Okay, go to the IFN transport a while ago. In model. And then go to the index. Can you see? And then go to this, the last lab, table classification. Can you try to open? Did you see this? So this is an example. You can select any data that you want here. you can also type your own data. Okay, so this is an example of data that I just put based on the book. Okay, so you have gender, car ownership, travel cost, income level, and transport mode. Can you see that? You can also get this. Yeah, and these are the data. Okay, the last part, okay, this is the output. Okay, this variables is the input. Okay, how many input? One, gender, car ownership, travel cost, income. So four variable input, okay, and then the last one is the output. Okay, so this is the data. So you have input, you have output. So descriptive. Okay, now I'm going to use IFN as the model. Okay, so I will train. What is the meaning of training? To find the model parameter. So this is the model parameter. I train. Oh, I got the IFN. Can you see? These are the model. The IFN model. You want to try on your own? You can go to the website. Okay. And okay, if you don't understand the meaning of A1, has, and so on, these are the meaning. Yeah. So gender, female, gender, male, ownership, one, and so on. Okay. So let's go down to the prediction. Okay. So this is the random test data that we want. Okay. Of course, in the test data, you have the input and the four variables input. Right? What do you want to get? The output. Okay, so when we click this, there. If this is the data, this is the output. The output is the, so this person will, female, have no car, okay, the travel cost is cheap and low, low income level. Most probably she will use bus, okay, with confidence level of 62%. So this is the meaning of prediction. Can you see that? Okay, you have the input, you want to find the output. The output is, of course, in the data well, correct? The output in this case is transport mode. Okay. So now we go to optimization, the third level, right? What is the third level? I know the output. In this case, I want to know who will use car. Click this, there. I can click always to generate new data. Can you see that? Yeah, so most probably the one who use data is the one who use car is female, okay, owning a car, okay, and with travel cost expensive and income level high. Okay, can change that. Can you try? Can you practice to try that? Is this interesting enough for you or not? So I have another data here, for example, whether you will play golf or not. Okay, okay, mammal. Okay, these are the data of mammal, right? So these are the class, the last one, the output, whether mammal, reptile, fishes, amphibian, and so on. And when you train, okay, this is only accuracy is only 75%, and these are the IFN. Okay, and now because this is mammal, so what is reptile? You can the data change, yeah? And whether this is you can check. Oh, this is amphibian, and so can you see that? You can create your own data, and then you can post there, and then you can get the result. Is it something difficult or easy? Give me a comment. Anyone want to share screen? Probably you want to say something or to show your practice. I will put you as co-host so that you can share your screen. Very quiet, so I don't know. Give me feedback so that I will know. What did you learn? When I said the 3 level of modeling, descriptive, predictive, prescriptive, do you understand? No? Or you don't? Can you hear me or not?
We can, sir.
Hey?
Yeah. Is it right to say that the descriptive model is a simulation of what was observed reality, sir?
Simulation of?
Of the observed reality.
Yeah, the descriptive model is not the simulation yet. So the descriptive model is just the relationship between the input and output of the reality. Okay. When we said simulation, that means you already asked, what if I change this?
So that's the third level already.
No, it's already in the second level and third level.
Predictive.
Okay. So in the descriptive, you only observe and describe what you observe.
Okay.
So, but when you said simulation, that always have what if I do this, right? So the example a while ago, is it clear or not?
It's clear.
It's clear.
But sir, is there are these model are applicable to all parts of the world? I mean, depending on the condition of the area, or we can still improve the model based on the condition of a particular place.
Model does not really depends on the place. Okay, the one that make unique for the place is actually the data. That means the parameter is unique to the place. The model is not. Okay.
Okay.
So when you see a while ago, the slide, let me share up the slide for you. Okay. So the parameter is the alpha. Yeah. Okay. So in descriptive, you learned alpha. It doesn't change here. This alpha. So this is the one that unique for your place. The model itself is not. It should be general. Okay, I hope this is clear. So now, in level 1, okay, when you want to understand, describe the phenomena, okay, now your goal is to understand, okay, what is the behavior, okay, based on your observation, okay, you start to understand what is this, okay, oh, what is the input, right? So you start to create meaning, some explanation, okay, in order to communicate what you observe. Remember, model is just language, okay, a way to communicate. So, two principles. Yeah? Number one is parsimony. Okay? Parsimony in a simple term means stingy. Okay, so simplify. Model is always simplified. Model is always wrong, okay? But some are useful. Model is not reality. Don't think that model is reality. Model is a simplified version of reality. So we exclude the irrelevant. For example, give an example, road. In modeling a road, say you want to create a highway, new highway. Okay. So do you include or exclude the bird and the ant, the animals, the rodent in the road? No, of course, right? You think, right? So you don't include the things that irrelevant in your model. Okay? You probably just model a road as a network, okay, and the vehicles and so on. So depending on what you think as relevant or irrelevant, okay, based on the familiar concept that you have. Okay, but look at this counter example. Okay, in Japan, okay, last time, yeah, there's a road, the highway that they want to build. Okay, of course, in modeling highway, you don't consider the animals or the plant, right? But some biologists found out, okay, that there are certain plant and an ant, okay, certain type of ant that is actually only exists in that place along the plan of the highway. Okay, so based on biodiversity principles, it is the highway that need to move to change the course, not the ant. Do you realize? Okay, it is the highway that changed the course. It's not the ant. Because, okay, our model does not include that, so we make the road straight, probably, okay, or the curve based on the contour, okay, of the topography. But we don't consider the biologies. Okay, but once you include that, suddenly things change. So the notion of relevant or irrelevant depends on the context that you include. Okay, depends on the second part. It is the perspective. Which one is actually important for you? Which one is not? Okay. Okay. What they do? What do affect or not? So, okay. So in level 1, okay, you include the input and output. Which one? It depends on your context. Okay. In level 2, you want to predict. Okay. So when you predict, is always based on the past. Okay. You want to extract the maximum relevant information from the history, okay, to learn about the future, right? So what change, what intervention that need to be done in the system, then you put that into numbers. You quantify that. That is the meaning of prediction. Okay. Next one is the control. To control, you have the target. Okay. You have certain behavior that you want to be achieved in the society, in the city, in transport system, right? Then you start to find out if I have this output, what will be the input? Okay, so this is better if you do by experimenting, yeah, in the model, isn't it? Okay, so look at this. You probably cannot control everything, right? Some part of the system you can only control partially. For example, the weather, yeah, will affect the farmers, but farmer cannot control the weather, right? But the farmer can control the decision what to plant based on the weather, right? Okay. Disaster always happen every year in the Philippines. Okay, you cannot control that. The incoming of disaster you cannot control, but you can control how you deal with it. Okay, isn't it? So you can investigate the robustness of your system, okay, by finding what is the sensitivity, the elasticity of each component of the model. Okay, this is all quantifiable. Okay, so when we say a model, that means you specify the dynamic behavior. So basically, a model is a specification of dynamic behavior of the system. Okay? Model itself is a substitute, okay, for an entity or an object or an event or phenomena or the system itself, so that you can experiment using the model. Okay, so when we said you want to model, okay, that means you abstract from reality, okay, into certain dynamical system. Okay, remember this, that modeling is actually serve as a language to describe the system at certain level of abstraction. Okay, modeling is a language. Okay, so this is an example of systems, okay? And these are example of certain models that you can use. Okay, for example, in the gas station, so you identify what are the entities. Oh, cars, yeah, trucks. Okay, what are the resources? Oh, there is a pump, there is attendance, and what is the phenomena that you want to model? Probably you want to check the queue. Yeah, this is the example. Of course, this is based on queuing model, so most of the example here are queuing, right? So in the restaurant, again, the same, yeah? The entities are the customers, there are some tables, kitchen, cook, and so on. So these are the things that you want to simulate. Yeah. In the hospital and so on, so you can also create. Think about the entities that you want to model, okay? And the resources, and then what kind of model that you want to create. Right. So there are many model types. So we can say we divide into two. Yeah? One is the physical model or scaling model. The second one is symbolic model. Okay. So in symbolic model, we have a mental model, our own thinking. We can put into diagrams, picture, matrix table, and mathematics. Yeah? So this is an example of physical model, right? So 3D physical model. Okay. Then you can blow in the lab, okay, with the color of the wind, so that you can see how this model can accept certain aerodynamic, for example, or the model of airplane can also do the same thing. Yeah? Or certain building can put against some certain earthquake. Okay? So you create a 3D model on that. Okay. So the scale model usually expensive to build, but nowadays using 3D printer, you can easily create quite cheap scale model. Okay. So the problem is if you use scale model, okay, you need to create a lot of different scale model, and usually it does not lend to optimization. Yeah, it can predict, but difficult to optimize. Okay, so mathematical simulation or simulation model belong to abstract, yeah, or symbolic model. What is this? Any set of rule, any set of relationship that describe something. Okay, that is to model a thing. Okay, this include, okay, any books, literacy, yeah, literary description, mental image in our mind, rule of the games, including legal code. Okay, they are called abstract or symbolic model. Okay, so let's discuss mental model. Okay, our mental model process the one that we concept in our mind. Okay, we manipulate into new arrangement. Okay, remember what we think is actually only model in our mind. Okay, that is not real things. What you think as true is not necessarily true, you know. They are only model in your mind. They are mental model. Okay. So mental model is a concept, abstraction based on your experience, based on your education, okay, based on certain context or purpose. Okay. Actually, you filter the world around you, okay, and then you modify it based on your own perception, based on the organizational perception, the culture and education and so on. So, isn't it? Okay. You are what you think in your mind. Yeah. So, what is the characteristic of mental model? Usually oversimplified. Yeah. Stable. When something happens contradict our mental model, you tend to dismiss that. Oh, maybe that's not true. Yeah. We are slow to learn, isn't it? So why? Because we have certain belief, we have certain attitude, certain opinion, okay, certain prejudice that we have. Okay. When we deal with certain complexity, we tend to confuse. Yeah? We tend to be dogmatic rather than observe, empirical. So, of course, mental model is part of our life. So we need mental model to think. Okay. But okay, so we need to realize that your thinking is actually model on itself. Okay. So ill-defined, mental model is ill-defined. Okay? We keep changing our own assumption. We keep changing our own purpose without realizing it. So sometimes assumptions are not easily be identified. Okay. You cannot communicate well using mental model. Yeah, it's not easy to communicate with other people, and you cannot manipulate it effectively. This is the characteristic of mental model. Yeah. So then we create other model. Okay. In order to communicate. So, for example, pictures. Okay. The X-ray, the chart. These are pictorial. Yeah? So when you create a road, usually you need a topographical map like this, right? So that you can see the alignment, the horizontal and vertical alignment. Yeah? So you can create diagrams. Yeah, the flow chart, the graph theory. Yeah, these are also pictorial model to illustrate certain interrelationship between the component input output of your model. Okay, certain sequence of the model. So next, okay, of course, this diagram can be used for decision making, okay, for optimization as well. For example, in network analysis. Okay, next one is to put this into matrix, into table, yeah, data. So this is also common model for decision analysis. Okay.
The best one is actually mathematics. The best model is not picture, is not table. Table, you just look up table. Okay? So using mathematics, okay, this is the most powerful, the most flexible, and the most abstract language. Okay. Why? Because this is the easiest model to manipulate, to analyze, yeah, to optimize. Okay. By doing the mathematics, okay, you can check the parameter, the variable, the function, the relationship between these variables. Okay. It can be, if you use it very well, it can be very powerful, but if you abuse it, it can mislead many people as well. Okay. So depending on the objective and the view of the system, you can tell lies just based on this mathematics and statistics. No? So these are examples of the simplified model of mathematics. Yeah. So of course we know revenue is equal to production times price and so on. Yeah. So profit is equal revenue minus cost. These are definition. Okay. We can also put it into dynamics. That means the population at a certain year, next year, T plus 1 mean next year is equal to the current. T mean here is the current, and then plus the birth rate, yeah, times the population, and minus the death rate times the population, and the net migration. Okay. So these are the example of model. Okay. You can also create model not based on logic, not based on definition, but based on empiric. Yeah? You do statistic and then you create some function. Okay? The sales is a function of any other variables that you put in. Okay? So this is empirical equation. Now, to create model, you require simplification. Remember, model is a simplified version of real world. Okay. The success of model is always tied to how you able to capture the behavior of the real world. Okay. So this is the common procedure, the step, okay, to create the model. First, you define the objective. What do you want to model? What identify the real world situation that you want to study, isn't it? Okay. And then you think about the concept to our solution. Okay. And then you make simplification. When you make simplification, mean you assume. Remember, what is assumption? Assumption means something that you believe to be true. This is your faith. Okay. The axioms. And the assumption is something that you believe to be true. Okay. After that, you probably need data to calibrate the model. Okay. And then you validate the model. Okay. I will discuss more detail what's the meaning of validate and calibration after this. Yeah. And then you ask what if. Yeah. So you simulate, okay, to solve the problem that you want in the beginning. Okay. Number one, a while ago. After that, you interpret. Yeah. You are human, you are not robot, isn't it? So you need to interpret your solution in terms of real world solution. Yeah. And then you verify. Yeah. Whether this answer is actually reasonable or not. When the prediction agree with the experimental result, then you can start to implement that. Yeah? Or you can come back to the improve of your model. Okay. So modeling itself, if you look at this, the same process a while ago. So modeling itself is a looping. Yeah. Is if the model flaw, then you need to modify again and again. You need to revise. So I hope in this class, okay, every end of the month you will present. Yeah. And then we can give feedback to each other. Yeah, we can learn from each other. Okay. So you observe the current situation. Okay? You set a hypothesis. Okay? Your guess. What is the proposed solution? Okay? After that, you create the mathematical model. Then you simulate. Okay? You gather the data to calibrate the model. Okay? Using the real world data, and then you validate the model using real world data also. Okay, and then you run with the current situation and your proposed solution. Okay, you control, you check the phenomena, the prediction, and the control. The 3 levels. Is this clear or not? Okay, so then you may ask, in my model, what variables should I include? Then I answer, what do you want to predict? What do you want to control? Okay. Something that you need to predict, something that you need to control, then obviously that variable must be there in your model, isn't it? Right. Okay. What kind of behavior that you want to see? Okay. What kind of policy on your system that you want to see? Then, of course, that part must be there. Say you want to change the cost, right? Then the cost must be there in the model. You change the distance, then the distance must be there in the model, isn't it? Obviously. Okay. You cannot predict something that is not included in your model. Yes, Glenn.
Sir, how do we account for unexpected variables, events? I mean,
Unexpected. What do you mean by unexpected?
for example, if we're doing modeling, transportation modeling, and then there are natural calamities that are not being incorporated in the model, how do we account for that?
That is different model. Okay. You don't include everything. Okay. Say you want to model calamities of transportation, then you can put that kind of stochastic, random event. You can put that inside your model. But if you want to create a road, okay, or you widen the road, or you change certain policies, no parking, or bike lane, bus lane, and so on. So, of course, this question is, do you want to include the calamities into your model or not? Okay. If you want to include, that's fine. Then you include the random event. If you don't want to include, that is also fine. Remember, the externalities, depends on the context, depends on your purpose. Modeling always contextual, depends on your purpose. What do you want? What is your goal? Right? If your goal is to predict the calamities, okay, or to cope with the calamities, then you need to include that. Okay. If that is not relevant to you, so you don't need to include that. So depending on you, what is your purpose? Yes, June.
Meaning, sir, we need to identify the limitation before we proceed to the modeling. Limitation, the data limitation parameters.
The relevancy. What do you, yes, limitation, that's true. Yeah, the strength and limitation must be there. But what is the relevance aspect of the component of the system that you observe? Okay. You need to include and exclude. Right? Certain things you want to include because this is the policy matters that you want to include. This is certain thing that you don't want. You don't want to include everything, your model become too complex, then you cannot even deal with it. Okay, and you don't have the data to calibrate that. Then it's just assumption without real things. So not really useful also, right? So you create your own model. Okay, what variables that you want to include. So important variables are, of course, the output, the final result of your interest, isn't it? Okay. And the policy variables, something that you want to control, something that you can decide. You cannot control the calamities. That's random event as an input. Okay. But what is the thing that you can control must be included in your model. Okay. Sometimes the external variables factor that affect the behavior of the system. Sometimes you can put into the model. Sometimes you don't. That's fine. Okay. In IFN, something that external I put in the cloud. That means I know that exists. I just put it as cloud. That means external to the model that I'm dealing with. Okay. So internal variables, sometimes we call it state variables, is something that inside your model. Probably cannot see by outside, probably can be seen. Okay. So for example, in mechanical system, yeah, in the animation a while ago, there are a lot of internal variables. There are position, there are velocity, there are acceleration, and so on. Yeah, in thermodynamic, you have temperature, entropy, volume, and so on. Yeah, so all of these internal variables are there inside. Yeah, the model is very complex, but there is inside is called state variable. Okay, something that inside in the system. So in dynamical system, okay, usually you have output. So I put Y as an output. T here represents the time. Okay, and this output depends on the previous output. Yeah. So last year is like that. So this year is like this. So this is can be like this. Yeah. So the model can be put as state variables. And then there is an external system output. Yeah? So this is the force that will change from externally. So you can put internally, and then you can put also externally. So yeah, if the things depends on itself in the internally, so this is called state variables. Yeah. So this is the state variable YT. Previous one is the summary of all the past input. Okay. So of course you can also include other variables. Yeah. So for example, you can put random events. Glenn was talking about it a while ago, right? So you can also put deterministic variables, which is only single value to estimate, or you can put certain lag information. Okay. Certain delay in the model. Yeah. So diagrammatically, this is what you have. So you have an input. This is the whole thing. The box here is represent the whole model. Okay. And the output is here. You have the input. Okay. These are the input variables. Okay. And the model is basically your rules inside. Okay. That will govern the state variables to produce the output. Then the output is the one that you observe. So the model itself is a system. Yeah, that relate the input to the output. This is clear. Yeah, inside, so model, you have certain rule that you set. So these are the function or the relation with the variables. Yeah. So now, on the top here is the real world situation. Okay. At the bottom is the model. Okay. At the left side is the time current. Okay. And the right side is the next time, next year. Yeah. So say this S here represent the real world situation, which is very complex. Okay, and real world itself will move with certain relation. F here is the relation or the function, okay, that move the real world into the future. Right. Then when we model, we don't model everything. We just extract certain things. Instead of the whole things, we just extract certain points here. Okay. And we create certain function that mimic the real world function. And then we get the output that mimic the output in the real world. Okay. Not everything, we just simplify. Okay. So this is equivalent mapping, he said. Yeah. Model is not reality. Don't forget that. So model is always wrong. Okay. So when you have a complex system, what will happen? Okay. So the same thing like a while ago, right? Now you have what is called macro and micro, right? So in the macro level, you see, okay, from bigger point of view. In the micro level, so this is the macro and A, and this is the micro, M-I, yeah. Micro. Yeah. In the micro level, is certain things that you see more detail. The animation a while ago is a micro level because you can see the detail how the car is moving. Okay. In the macro level, you don't see that. You see the graph with this only the numbers of flow, density, speed, and so on. With this aggregation of this micro level. Can you see that? Okay. When you, in the real world, the same thing. Okay. When you buy and sell, that is the micro level. In the macro level, you will see the GDP of the country. Right? You will see the inflation, macro level. In the micro level, is dealing with each individual. Can you see the difference between the macro level and the micro level? Okay. Whether you're dealing with aggregate level or individual level, that's the difference between macro and micro. Okay, so you can also include, okay, time and space. Okay, so you can include time and space as your part of the variables. Okay, if you want to see the effect of time, of course, time must be there in your model, right? If you want to see the effect of space, then space must be there in your model. Okay. So you cannot see the effect of space, for example, the change in the space, without you put that in the model. Okay. The things that you want to include is the thing that you want to manipulate, you want to intervene. Is it clear? Okay. So usually we can also include agent. Yeah. So agent means is a term. Yeah. So for example, each person is an agent. Each pedestrian is an agent. Each vehicle is an agent. Right. So agent can learn, agent can adapt, agent can connect with other agent, for example, with the network. Agent can interact with the environment. The car is moving in the road. That means the car must detect the other cars. The cars must detect the environment, the boundary of the road. Right. Okay. So agent can be diversified in kind, in attribute and values. Okay. Vehicles can be derived into cars, motorcycle, bus, different kind. Right? Maybe jeepneys. the trucks. Okay? You can put different size, no problem. Okay, once you put the concept of agent in that move in the space and time, then you start to see different things. Okay, if you just use mathematical like y, t, and so on, that one is dynamical system. You only include time. In the network graph, you only include space, no time. In cellular automata, you can include time and space. Okay? In the multi-agent system, you can include all. So which model you want to do is up to you. Okay, so this is example of disease model, and that's the simplest one. Yeah. We call it SIR, yeah? Susceptible infected recovery. So okay, the probability of susceptible depending on the infected and the total population N. And the probability of infected depends on the susceptible S and the total population N. Okay, the probability of recovery, yeah, depending on the infected here and the total number of population. Look at this. This simple model do not have any space, yeah, no geography, no friendship connection, no time. This is only flow. This is macro level. Still being used in the medical society. Yeah, last time during COVID, a lot of people write paper about this, isn't it? But when you start to see in the micro level with time and space, then you start to see the connection of each person, whether they are friend or not, whether they are have interact or not. Okay. Then you can, from the micro level, you can extract into macro. Yeah. Right. So you can aggregate this. From micro, you can go to macro. Yeah. From macro to micro is difficult, but from micro to macro is easy. Right? Simply aggregation. Yeah, you just take average, for example, or you take the median, or you take the distribution of that. Okay, you can get the macro level, the flow. Is that clear or not? Okay, so example here in traffic, yeah, we have the static model, flow equal speed times density. So this is called fundamental traffic flow formula, isn't it? Q equal to U times K. Okay, so better, still static, you can create network flow model. If you want to go more detailed, you can create the animation. So you go to the micro level. Each vehicle as an agent move in the road network dynamically, like a while ago I showed you, right? If you want to put in the macro level, you can just see the dynamic of the network flow, okay, using IFN, for example. The old model is basically static network flow. Any question, comment? So now, when you create a model, okay, what is the basis of model usefulness? Okay, when you say, oh, this model is not valid, okay, look at this. Yeah, model validity is actually relative. Yeah, so the usefulness of a mathematical or simulation model, okay, should be judged in comparison with mental model or other abstract model. Okay, when you check this, whether the structure is clarified. Remember, model is a language, yeah, to communicate our thinking with others. So whether the model actually clarify the structure of our thinking, whether the model, okay, can be stated, what is the assumption, what is the thing that invariant, the thing that must not change. Okay, can you see the consequences in terms of the time, in terms of the behavior? Okay, that is how you check the validity. Okay, so J. Forrester is the father of system dynamics. Yeah? So this is from MIT. So I quote here. Yeah? By constructing a formal model, okay, our mental image of the system clearly exposed. Yeah? General statement about the size, the magnitude, the influence are given numerical values. Yeah, this is how you model, isn't it? So as long as the model is so precisely stated, one usually asks how he knows that the model is right. So a controversy often develops over whether or not reality exactly presented in the model. Once you create the model, okay, people will start questioning about this is not real. Model is never real. Okay? So such question means the first purpose of modeling, yeah, which is to be clear, to provide concrete statement that easily communicated. So remember, the purpose of modeling is to communicate. Yeah. I hope with this give you certain understanding. Yeah, you are not afraid to model. Okay, so the model is representation of reality. Yes, we can never prove that any model is exact representation of reality. So you should not judge the model based on absolute scale, yeah, condemn them to failure to be perfect. Of course, model never be perfect. Okay, but you judge on the relative scale, okay, whether they can succeed in clarifying our knowledge, in checking whether you can get insight into the system through our model. Okay. So when the model is already reduced into diagram, into equation, okay, when the underlying assumption I already examined, and you can communicate with others about this model, okay, you can compute the time pattern, the behavior based on that model, then you can reasonably hope that you already understand the reality better through this model. Okay. So how about data? Most students will always say, I don't have data. It's very difficult. Okay, look at this. The purpose of data is to validate and calibrate the model. The data itself will not solve your problem. Okay, don't rely too much on your data. Okay, the purpose of data is to validate and to calibrate the model. Okay, so what is model calibration? So it's a process to determine the value of the parameter. Remember a while ago, I said y is a function, okay, of the input. Yeah, the output is a function of input and the parameter alpha. So when we set model calibration, that means you want to decide what is the parameter alpha here. Okay, so that means you feed your data into the model. Okay, so what is model validation? So model validation is a process, yeah, to test. After you calibrate the model, okay, using different data. Okay, I will draw here. Okay, this is your whole data set. Okay, so you divide into two, for example. Okay, the first part of this data, okay, this is you want to use for calibration. Okay, so you want to use for calibration. Okay, so calibration means you get the model parameter. Now, after you get the model parameter, now you have the function, right? The y equal to the function of x and alpha. So the alpha is already given based on this. Yeah. So then the second part of this is now I'm using this alpha, the model that you already calibrated, okay, to test. Now I get the input. Yeah, this is the X and Y, right? So this new, the input that you did not use for the calibration, now you put it here. Okay, whether you can get the actual output or not. Check. Can you see that? Okay, if you can see that the actual output from the data is the same as the prediction of the model, then means they are quite much. Of course, there's an error, but how much is the error? Right? Is it clear? The difference between calibration and validation. In calibration, okay, this data you use to get the parameter alpha. Okay. In validation, you already use the model to predict, and then you compare the output based on this. So this is, we check whether we build the model, yeah, right or not. Clear? The third one is called model verification. Okay. So we must check after you build, you validate the model, you calibrate and validate the model. Okay. Then you verify. How do you verify? You check in the real world, yeah, whether this is actually certain phenomena, certain features is actually clearly also happen in the real world. Okay. So are we really building the product right or not? Okay. You verify whether the model, okay, similar to the reality. This is called verification. So you interpret the meaning of the model here. Is that okay? So this is the next topic. Question? Anything to discuss about model validation, calibration, verification? This is clear? Yeah. In transport model, you create model. Yeah, in your group project. Yeah, you can use the tool, you can create your own. That's even better. Yeah. So the next topic is simulation. Of course, simulation means you want to see the step-by-step behavior of the pattern. Okay. The process to get the numerical solution, the what if. Okay. So simulation is a mathematical model that describes the behavior of the system over time. Okay, so this is a software product. Yeah, it's not just a mathematical formula. Okay, so using simulation, yeah, you can learn by doing. Okay? You learn about the system, you run that and run, and what happened if I change this? What happened if I change that? So you experiment, okay, using the model or the simulation model that you have. Okay, so always in the simulation, you perform what if analysis. It's a very cheap way if you can already build the model. Okay, you have your own toy, right? So you can understand the reality better based on this. Okay, that is simulation. I hope we have a better understanding through this. Yeah, so these are the quote in the simulation. Yeah, so what kind of game are you playing? Right? So you cannot study the system by stopping it. That means you simulate, right? Yeah. And in Star Trek, yeah, it always says run it again, right? Yeah. So that means you simulate. Yeah. So any simulation, in some sense, is always the cartoon of the reality. Yeah, they are not the reality itself. The reality is very complex. Okay, so but when you can capture the essence of the situation, we hope our simulation can capture the essence of the real world that we want to solve. Okay, so the purpose of the simulation is to develop the policies. Okay? What change we need to do in the existing system in order to improve. Okay, that's the meaning of policy, right? You want to improve the system performance. Oh, right now it's traffic congestion. How to solve it? You need to reduce the traffic congestion level. Right. So that means you need to find a way, experiment using your system. Okay, in the model, not directly in the real world. Imagine after you widen the road, yeah, in certain part of your city, okay, apparently doesn't solve traffic congestion. It make congestion in other place, which easily you can detect using the model, but you don't do it because you are stubborn, telling that I need to just implement this because I have the money. You are wasting taxpayer money. Yeah. So I hope this, after you learn this modeling class, you will not do that anymore, right? Okay, June.
Sir, the problem in the Philippines that when we do the traffic impact assessment for a certain project, for instance, we only cover around the 500-meter radius or 1 kilometer radius of the project site. So the impact of the traffic is actually after the 500-meter radius.
That is very limited. Okay, you are talking about 500-meter
to 1 kilometer.
Yeah, that is very limited. Okay, you should increase the radius to 5 kilometers. Okay, when you put in the localization of that buildings or that developments, then and then you change the system there. Okay, what you don't see is the actual impact to the other place. Okay, when you use the model, you can start to see, oh, you can use IFN last year, the students always say, oh, I start to realize when I change this part, the other part changes. Okay, then you start to know. Okay, the other part changes. That is the one that you start to realize, hey, you change, you myopia. Yeah, you think in the short term that you change here, but you don't consider other place that actually have impacted because of your change here. That is very bad, isn't it? But you have the model, so you can just change this, widen the area and so on. That is easy. Okay, so you can start to do better way, not just based on the rule, which is still not yet perfect. No? So if the rule said only 500 meters, that is not enough, I guess. Huh? So you can test the new concept. You can test something that you want to implement, okay, before the implementation. That is the best way to do. Okay, you can gain a lot of information without disturbing the system, isn't it? So you don't need to process the whole system. You can run the simulation. Okay, that is the essence of modeling. I hope you understand this. Okay. Why we model? Very important, isn't it? Cost efficient. Okay. Next. So to demonstrate the model, you need to show the internal process, yeah, of using simulation. Okay? And sometimes, you know, if you want to use mathematics only without simulation, what's the problem? Okay, analytical solution of the mathematics sometimes very complex. You cannot even solve it mathematically. Okay, and you know, if you can use mathematics to solve without simulation, that means you don't need to program. Use mathematics. Just use the equation, you solve it, you get the better result. But if your problem is too complex, you cannot use mathematics, you use simulation. Okay. So if the experiment of the policy is too costly, like the road, right? Like urban planning, 100 years impact, how do you know? You already dead by that time. Right? So you can simulate. Yeah? Too dangerous. Yeah? You can compress the long-term effect, yeah, of the city growth, for example, okay, using simulation. Okay. Okay. So when you have the analytical solution, right, then use that. You don't need to create the simulation. Okay. So in the past, usually we use mathematics. Yeah? That's called analytical solution. So if you already have that, so use that. Okay. So if you don't, then because analytical solution allow direct computation of the system, okay, this is actually better if you can solve that. Yeah. The problem is analytical solution sometimes very complicated, and only a few people can solve that analytically, yeah, mathematically, isn't it? So then simulation is probably the only way to solve. Yeah. Certain things you cannot even solve using mathematics. You need to use simulation. Okay. So simulation does not give you general solution. Okay. Simulation only give you particular solution. So it will not tell you all the possible behavior. Mathematics do that. Yeah. Mathematics can give you general solution and can give you all possible behavior. Simulation cannot. Because simulation is just one run, certain path. Okay. So it's not an abstraction. So it only gives one-time history of the system under certain initial condition, under certain coefficient. That is simulation. Okay. So that means if you can solve analytically, do it. If you cannot, then you need simulation. Okay. What is the reason not to use simulation? Okay. When analytical solution is simpler and easier, don't use simulation. When the model development is too costly, time-consuming for the organization, don't use simulation. Or when the running time is too expensive for today's computer, don't use simulation. Or when the probability, yeah, sampling error is actually very big, then it's useless to use simulation. So this is not panacea. Okay, there are tools that we can use. Okay, so not always the tools is available or good. Okay, so simulation requires certain specialized training, sometimes can be costly, yeah, and sometimes involves so many statistics. So those are the disadvantages of simulation. So this is last but not least topic on the modeling is this one, yeah. So be very, very careful with the unit and the dimension. Okay. When you said equal, that means the dimension of the left-hand side and the right-hand side must be the same. Okay. So he go garbage in, garbage out. Okay. When your data is inaccurate, don't expect the output will be accurate. Okay. When your data is garbage, don't expect your output will be perfect. It should be garbage also. Okay, the model cannot solve the problem by itself. Okay, so remember, data model mathematical relationship is not the solution. Okay, you still need to analyze, you need to simulate, you need to verify, and then you interpret this to give the possible solution. You are the human. Yeah? You are not robot, right? So you are the human who will give these ideas and analyze and give possible solution. Okay, so sometimes, okay, when none of the mathematical or simulation solution makes sense, then you probably need to check the assumption. Probably your assumption is the one that is make it wrong. Okay, remember, any model start with assumption. What is assumption? The faith that you think this is correct. Okay, when everything you have done, and then you start to see, oh, it doesn't make sense. Okay, the result doesn't make sense. It's not representing the reality. That means you go back to the original one. What is that? The assumption. Okay, probably you need to change the assumption in order to make better model. Is that clear? Okay. So sometimes the model cannot provide easy answer to the complex problem. So this is the danger. Okay. Once, quite often that you become involved in the model, okay, you think that this model is the reality. Again and again, I'm telling you, beginning. Yeah. So you become so involved with the model, with your solution, you forget that it is a model. It is not the actual system that you analyze. So in the beginning, I tell this, okay, so that you will know later on. Yeah, when you get too detailed, okay, and then you will think, what? Why like this? Why like that? So you start to forget, okay, that this is a model. This is not reality. So yeah. So good model and good solution may represent good approximation of the solution in the actual system. Yeah. But be careful, this is not the solution of the actual system. Okay. I hope by this you start to realize many things. Yeah? There are misconceptions, yeah, that larger, more complex, more sophisticated model is better. But okay, the reverse is actually true. Yeah. Have you heard about Occam razor? Huh? Have you heard about Occam razor? So, okay, you should not force the problem to fit certain model type. Yeah. So you need to learn the model, and certain model is useful for certain problem. So it's often once becomes so enthralled with certain type of the model, and then she tried to place every problem in that format. Yeah, including me sometimes doing that. Right? So what is Occam razor? Yeah, William Occam is a Franciscan monk. Yeah, in 12th, 13th centuries. He said this in Latin word. Yeah, so the English meaning plurality should not be posited without necessity. Yeah, that means you prefer the simplest hypothesis that is consistent with the data of the empiric. Okay, so if two theories, two hypotheses explain equally well, one is complex, the other one is simple, you prefer the simple one, not the complex one. That is Occam razor. Okay? So the short hypothesis, the simple hypothesis, is less likely to be coincident just because of luck. The long hypothesis that fit the data, that's probably because of luck, coincidence only. Okay, so that's why, okay, when you have several models almost equally well, Okay? The simpler one is preferred. Okay? Accommodation. Okay, so I give you example. Okay, so you can check Wikipedia, Weierstrass approximation. Okay. So Weierstrass approximation theorem states that any function, yeah, in the closed boundary, yeah, can be approximated simply by polynomial of any degree of accuracy. Yeah. Polynomial is one of the simplest form of model. Okay. The problem is actually overfitting. Okay, I will show you example. Okay, look at this dot, dot, dot. We have a function and we have x on the horizontal axis, and this is the function. So let's create a model of this simple data, only one two dimension. Okay, so the first model is this black. It's a linear model. Okay, the second model is the blue one. It is quadratic. Okay, the third model I use cubic, the red one. Okay, the fourth model I use Fourier descriptor. Yeah, so which one is better to approximate? Which model is better to approximate this dot, dot, dot? The plus here represents dot. Anyone? The black one, the blue one, the red one, or the green one? Yes, Joven.
Sir, I think the based on the graph only, sir, I think it's the black one, sir.
The black one. Okay. Joven
But
said,
if we can compute the regression or the R value,
no, this is
we
all
can-
regression, you know? These four models based on regression.
the R value, sir, the exact decimal value, if it's the closest to one, then we can get that one.
That is called overfitting. You see this. The less the R value is this is less than 1, clearly, because this is not matching here. Okay.
Yes, sir.
This one is better than the black one, closer to 1. Okay. And then this one is exactly 1. The red one is exactly 1. Why? Because it go to its
Touches all the
point.
points.
Okay. And then the green one is also exactly 1. So your argument is not correct, right?
Yes.
So which one in that case? Yeah. Based on Occam ratio, which one?
The red one, sir.
The red one is overfitting. Yeah. In fact, when the R value is 1, that is overfitting, probably. So you must check more detail. Yeah. So the R value 1, that means here it matches exactly here. What is overfitting? Overfitting means the model match exactly with the data. Calibration. You calibrate based on data, right? Calibration match perfectly, no problem. But validation is not. What is the meaning? If you have another data that you put there, that you hide a while ago, you put there, it will not match. Okay? Overfitting is only match with calibration, but doesn't match with the validation. So, okay. So in this case, the blue one probably the best, closer to that data, assuming this is actually not outlier. This is actually real data. Okay. If this is actually outlier, the black one is probably the best. Right. So when the red one and the green one is clearly too complex. Why? When you have a data, when you have a new data here, it doesn't match at all. Yeah, this is purely say you cannot extrapolate, you cannot predict using the data, using the model that is actually overfit. Clear? Okay. So with that, so we finish the certain part of our lecture. Any question? Any discussion? About modeling? Okay, so that is very abstract. So let's go to the next topics in Moodle. You go back to Moodle. Transport modeling. Right. So we've done this one. Yeah. Modeling fundamental. So let's discuss the next one. Yeah. Land use activity interaction. Is that okay? You still have energy? Oh, before that, before we go here, can we have one person as your representative? And then that representative will collect the phone numbers and then email. And then if certain things, for example, certain holiday or certain calamity happens, so I will just contact one person and then the bidder, the class representative will contact the others. Is that okay? Who wants to volunteer? Become class representative in this class. We need one. Anyone? Come on. Ah, Joyce. Okay. Okay, so Joyce Rivera will be your class representative. Is that okay? So Joyce, please collect the phone number. Okay. I emailed last time to all of you, right? So you already have the email from all. So that you can communicate faster. Sometimes email is very slow. Okay. So in that case, let's go to the next topic, which is land use, activity, transportation, interaction. Okay, on this, I will show the Can you see my slide? Yes. Okay, so this is our first topic. Go to the model of land use, activity, and transportation. I used to teach, this is like one whole semester, just this course, but this is like an introduction, so I just put it probably just today or next week. Okay, so let's go to the general introduction. Open transportation problems, and then we discuss about land use activity and transportation interaction. Did you take any course on that title? Did you learn about land use interaction with transportation in other course? Not yet. Okay. So, and then we will create a very simple model of demand supply analysis, yeah, which is based on linear. Okay, so let's discuss the first part. Yeah, what is transport problem? Anyone? So, of course, the obvious one is congestion, right? Okay. The next one is probably accidents. So these are the two main transport problem. So, have you ever faced any transport problem? So similar to doctor, okay, So doctor face the patient with is sick. So do we like to be sick? No. Okay. So do we like the transportation? Oh, sorry, the chart I cannot see. Reliability. Okay. So reliability is one problem in the Philippines. Yeah. What's the meaning of reliability? Say public transport is not reliable. That means
In terms of time of arrival, sir, for instance, in terms of
so how do you solve that problem?
through, I think, additional transport mode or additional road network.
Is it?
One, I think so.
Okay. You check the demand. When you check the demand, you check the demand over time. Okay. And then you create a scheduling. Okay. And you create a model to do this scheduling. Okay. Then you can check how many vehicles needed for this particular route. Isn't it? Then you start to say, oh, this is not enough. Oh, this is enough. Okay. If this, oh, this is actually offer. Possible, right? I don't know why all the bus seems like run in EDSA. Okay. Why no bus in other place? See? Because the demand is too high, is it? And why bus and MRT run in the same, in parallel? Isn't that strange? Why they are competing each other? Something is wrong, right? So you don't have integration, meaning why the jeepney is also run in the same along EDSA, as if the whole Metro Manila is only one road. So jeepney is supposed to be feeder service from the housing to the main hall, which is the main public transport is supposed to be for the MRT or bus. Okay, the MRT is very expensive to build, so only certain line. The bus must go, okay, passing only intersect with the MRT, but they must go the other way, not in the same route and then in parallel with the MRT and then competing with the MRT. Isn't that? Right?
Sir, for the case of the EDSA busway, I think it's more of a supplement to the current MRT because the MRT is over its capacity.
If it is over, so you increase the frequency. You did not increase the frequency.
The problem there must be on the number of units flying that route.
That is unreasonable because the number of unit you make profit out of that. So right, that unreasonable. So the purpose is to create profit rather than to serve public. So in that case, right, it's not the way to do. Having a public transport to become a profit company that you want to reduce the number of train in order to make profit, correct? Rather than setting the real capacity choice.
Yeah, aside from the capacity, maybe it's also about the operational hours. They just chose to have certain services from this time to this time and not really providing services
So why
24/7.
don't
You
you
agree
change the
about
rule?
public services.
So you change the rule.
Yeah.
Right? In Singapore, 51% belong to government, the share. So that means the control of the government is still there. If you put everything under the private, so you cannot even control, then you lose everything. Correct? So the government cannot control. How can it be? Yes, Joyce.
Yes. I'm not so sure about the train stations. If they have key performance indicators based on their agreements with the Department of Transportation. But as to the land public transport sector, for the buses, the jeepneys, that kind of KPIs is also not yet established. But yes, it's one of the mobility policies that we can actually explore.
Okay, so I believe over time you can improve that. Okay, but at the same time, the reason that they put is actually unreasonable. Okay, so I mean logically, I'm not commenting on the who, right? I'm just commenting logically. Okay, it's illogical to say that this is not in capacity, but your frequency is so long. In fact, MRT is supposed to be only 3 minutes, not 15 minutes. Right. So, and then you are saying not enough capacity. That's not true.
Not to mention the cruising speed.
So that can be improved by the alignment of the rail. Okay, so again, transport problem, yeah, integration, lack of integration. Meaning, look, if I go from my house to my office, I need to pay jeepneys. I put the tricycle, and then after that, I use the bus or the MRT. Okay, and then go back again. I use the another jeepney or another tricycle, or I walk. Right. So there is no integration because I still need to pay all this along. You already have BIP card. Why don't you just pay it at the same times? Why you need to not integrate this? Right. So this is one. This is your homework. Okay. And too many transfer and waiting. You can create an app so that they will not wait. So by walking certain part, you can right. So that you can the schedule you can make it so that you can see. So there are a lot of things you can improve actually. Right. So certain people, okay, whatever it is, because of lack of privacy in public transport, they don't want to use public transport. So we call this captive and choice. Okay, you are captive to public transport, or you are choice to public transport. You are captive to car, meaning that you have no choice except to use car. Possible? Okay. So my question to you, simple. Huh? When you create a policy on public transport, who is your target market? The one that use car, captive to use car, the one that use public transport already, or the one have choice to use either car or the public transport. In terms of policy, think about it. Say, in terms of policy, you want to improve the reliability, you want to improve the cost, you want to improve the waiting, the transfer, the scheduling, isn't it? That policy that you improve, isn't it? So after that improvement, will people still use public transport? Those who are already using public transport, they will still use public transport. So that policy does not affect them. Correct? So your policy is useless for them. Yes, it's useful because their service is improved. But in terms of number of demand to the public transport, it's useless. Okay. Those who use car, okay, class 1, even whatever you improve in the public transport, they will still use car. Right? Makulit. Stubborn. Right? So, they are not your target market. Why? Whatever you do, they will not change. So, your policy target market is actually those who have choice. They use car now or in the future. Okay? They have choice either to use public transport or car. So the middle class is your target market. It's not the poor, it's not the rich. Am I make it clear? Okay. Yes. So if that is true, right? So the improvement that you target should be in the middle class. Right? Say, for example, yeah, in Bangkok last time, in 1990s, yeah, they have a free bus. Why? Because this is for the poor. Okay, provided by the king at that time. Yeah. Free bus. When you ride, zero cost. It's subsidized by the government. But you need to stand there. The bus is not air conditioned. Free to use. They are for the poor. Okay. The MRT is for the middle class. Why? Expensive, not cheap. If the MRT is cheap, what will happen? The poor will ride the MRT, but MRT system is expensive, isn't it? When you put the price of MRT cheap, what will happen? A lot of people will ride MRT. Correct. They will not use the free bus. What will happen? The choice people who are supposed to use from car to public transport, they will not use public transport. They will use car. So who is the problem? Your policy is your problem. Okay, you make the price of the MRT very cheap. Then people who has choice will not go away from the car. Okay, they will still congested the road. Okay, and then the poor will still feel the same thing. Okay, the rich also feel bad because the road is also congested. So everyone not happy with this policy actually. Now let's reverse, yeah, in the simulation of thought. Let's reverse the situation. Okay, you provide free bus. Okay, and then you improve the MRT, the reliability, the costing, yeah, increase the price, increase the headway, meaning every 3 minutes you have MRT, right? So what will happen? People who supposed to use car, they will shift to MRT, the middle class, right? Oh, I don't, and then you increase the parking fee so that they don't like to use car because the parking is very difficult to find, right? So what will happen? Those who use car still use car. Those who use bus, the free bus will still use bus. But the middle class shifted from the road using car to use public transport. So less congested, everyone happy. Can you see that? So the money that you get from this taxation and from the improvement, you can put to subsidize the bus which is free. You can model this. Right. This is policy analysis, no? What do you think? Yeah, I hope based on this simple simulation of thought, yeah, so you can start to see how you see the policy that you affect. Who is the real target market? Accident, in terms of accident, the same. Okay. Accident have a number of accident, okay, injured and fatality. Okay. When you create highway, right? The bigger highway that you have, what's the meaning? High speed, right? So the higher the speed, what will happen? Fatality increase. Okay. Congestion is actually a blessing in disguise. Why? When there is a congestion, very slow, the speed is very slow, probably there's an accident, but the fatality reduce. People not dead because of accidents. So you can model this. Yeah. So many different models you can create just based on the problem. Okay. Now I want to tell you very important things. Yeah. These are other transportation problem in terms of universal design. Okay. People do not have space for disabled, elderly. Walking is not even there. Okay. Air pollution, noise, and so on. Okay. And of course, undesirable land development and the land value become crowded, or unequal social impact. Okay. These are the other transportation problem. Okay. Now, one thing I want to say is this. Transportation is a derived demand. Okay? Transportation is a derived from activity. So when you want to solve transport problem, do not just in the transport's point of view. The way you solve transport problem is to broaden your view so that you can start to see, including the land use, including the activities. Okay. The fact that you like this course because we are on Zoom, right? Online. So during the COVID, okay, many courses are online, okay, and then the number of traffic congestion reduced significantly, almost nothing. Correct? Okay. So now the COVID gone, so we start to implement need to be offline again. So the question is why? Right? Do we really need it? Okay. When your transfer is actually information, okay, you don't really need, okay, to be offline. See, information exchange like a course like this, a seminar or a lecture, right? Including all the government office services, yeah. You need to get certain ID, certain card, okay, paying the tax and so on. These are all exchange of information. In that case, you don't need to make it offline. You don't need to be there. Okay. Nowadays, we have what is called information highway, which is the internet, isn't it? So you can shift the activities to the internet. Then what will happen? The congestion reduce so much. Of course, that's require change of culture, change of trust, change of management. So solving traffic congestion is not merely in transportation. Okay, solving the activities problem, the culture, the management, how to improve the trust between employee and employer. that also improve the traffic congestion. Can you see that? Okay. So I hope you remember that transportation is the derived demand from activities. So if you want to solve transport problem, solve the activities. Okay, any question, any discussion that you want? We have 4 minutes. Yes. Any comments regarding policy of Singapore in car ownership? If car in 10 years old, the owner has option to dispose it and he can continue provide owner if willing to pay the road tax. That is good. Okay. So in Japan also the same, yeah. So if you want to own a car in Japan, for example, you need to show the proof of parking lot. You can rent, but you need to prove the parking lot. Without that, you cannot own a car. You cannot even renew the car if you don't show the ownership of parking lot. Okay, and then the age of the car that represent the air pollution actually. Okay, so it doesn't actually affect it if you are using e-vehicles. Okay, so the number of age of the car, 10 years old option in many countries, that because of the air pollution. So we want to, because the older the car, the worse the air pollution, isn't it? Okay, so that's the idea behind that. Okay, so I don't think adopting the policy ownership of the car alone can solve traffic congestion. Okay, so the one that indeed can solve traffic congestion is adopting the culture, adopting the culture of online. That surely will improve the condition. Why? Okay, every morning you need to go from Quezon City to Makati, 2 hours work, and then 2 hours come back. Every day, 5 times in a week, facing the same people, the same traffic again and again. When that work can also deliver over the internet. And why? Almost the same time of the work also. When you can actually make flexible time. Activity change. Can you see that? Yeah. So I hope you can develop things. Yeah. So thank you very much for today. Thank you for listening to my blubbering lecture. Yeah. So see you next week. Yeah. So today's assignment is simply the group projects grouping. Okay. Okay. Thank you. Okay. Bye-bye. Yes, Glenn, you want to say something?
Sorry, sir, just a clarification on the groupings and the topics. Can we still change the topic when
Topic you can
we
change, but group don't. Is that okay? The topic you can still think until end of next month. So this topic is tentative, so you can put 3 or 4, no problem. But grouping don't change, yeah. Is that okay? Because when you put the grouping, I will input that manually to Moodle, so that you can next time you can just submit one person to all. Is that okay?
Yeah.
Okay, thank you.
Yes, sir. Thank you.
Yes. Okay, then I will end this. Intentional workday and alternative work. Yes, so let's do that. I propose that to your boss. Okay. See you.